All right, are you ready for more pain? I think this one won't be as bad as the last one, but we'll see how it goes. All right, so we have our first eigenstate there. Let's go ahead and get the second one. So we have our other eigenvector, our negative h bar over 2. And remember once again, so if we apply our Sn operator to some unknown vector, what we should get back is our eigenvalue. So we're going to be doing negative h bar over 2 this time. And then our vector back. All right, so we'll go ahead and plug this in here. So we have h bar over 2 cosine theta, sine theta e to the I phi, sine theta e to the negative I phi, and negative cosine theta. And then a and b, and should equal negative h bar over 2, a and b. All right, so if we do a times cosine theta, we have a cosine theta, and then b times this is plus b sine theta e to the negative I phi. All right, and so what we should get is something that looks like this side is going to equal this here. So equals negative h bar over 2. This is going to be h bar over 2. You've got to bring this down also. A and b. We don't really need to do this b term here. It's going to end up being the same thing, so I'll just save the time. But we want this side to match this side so that we know that this would equal that. Well, these don't match right here, but we can make it match by just distributing out that negative. So we put that negative inside this vector right here. Now this outer term matches, so then we can assume that these inner terms match, which means that this will match this. So that just means that a cosine theta plus b sine theta e to the negative I phi is equal to negative a. And then we can go ahead and solve for b. So I'll bring this over here. So we have b sine theta e to the negative I phi equals negative a minus a cosine theta. We'll go ahead and pull out this negative a. So b sine theta e to the negative I phi equals negative a times 1 plus cosine theta. We can multiply both sides by e to the positive I phi. That'll cancel out this term. So b sine theta equals negative a e to the positive I phi 1 plus cosine theta. And then we'll divide both sides by sine theta, and that'll give us our b. So our b is going to be equal to negative a e to the I phi 1 plus cosine theta all over sine theta. Okay, so that's our b. And again, so our normalization factor is a squared plus b squared equals 1. So a is a. B is going to be this. So negative a e I o u 1 plus cosine theta all over sine theta. And remember to square this, and that's going to equal 1. All right, so let's go ahead and pull a couple things out here. So we still have our a squared from here, plus, and we can pull out that a squared. It's going to just stay a squared. It is negative, but because it's the magnitude and because it's going to be squared, the negative is going to fall out anyway. So if you want to keep the negative in there, you can, but it doesn't really matter. This e to the I phi squared is going to cancel out because it's going to be multiplied with its complex conjugate. So e to the negative I phi, and that's going to become 1. So that gets canceled out. So then we're just left with 1 plus cosine theta over sine theta, and that's all going to be squared equals 1. Let's go and factor out these a's. There's a squared times 1 plus all this junk, so 1 plus cosine theta over sine theta. That's going to be squared. Okay, so then, yeah, we can go ahead and divide all that stuff. So a squared is going to be equal to 1 over 1 plus, and I'll do the same thing I did in the last video. I'll square the numerator and denominator separately. So 1 plus cosine theta squared over sine squared theta. All right, this 1, again, can be sine squared over sine squared. So we have 1 over sine squared theta over sine squared theta plus 1 plus cosine theta squared over sine squared theta. So because we have the common denominator, we can combine this fraction into one fraction here. Boom. All right, then let's go ahead and we can flip the fraction now just to kind of shrink it down. So it's going to be sine squared theta over sine squared theta plus 1 plus cosine theta squared. And let's go ahead and expand out this term here. So 1 plus cosine theta, 1 plus cosine theta. We have 1 plus 2 cosine theta plus cosine squared theta. All right, so I'll put that down here. So that's going to be sine squared theta over, let's write all this out. So we have a sine squared theta plus all this. 1 plus 2 cosine theta plus cosine squared theta. All right, so we have a sine squared theta and a cosine squared theta. Those can combine to make 1. And then I go ahead and make some room up here. I'll rewrite this up here. So we have, I still have our a squared equals, and then numerator is sine squared theta over, and then we have 1 plus 1, so it's going to make 2, plus 2 cosine theta. Okay. And that's kind of, this is kind of where we kind of deviate from the last one. We kind of followed all the same steps to get to this place, but I think we had 2 minus 2 cosine theta in the last one. So we use some more trig identities for this. I think the trig identities for this one are a little bit simpler at this point. At least I found some ones that are a little bit simpler. So first of all, let's do the denominator. And so we do have a trig identity. We have cosine double angle identity, which is a few of them, but the one we're going to use is cosine 2 theta is equal to 2 cosine squared theta minus 1. That's not what that looks like, though. So let's go ahead and rearrange this a little bit. So we have 2 cosine squared theta equals cosine 2 theta plus 1. So I switched the sides, but I just added 1 to both sides. So cosine 2 theta plus 1. All right, so then we have, what do we got here? First of all, let's go ahead and sine squared theta over 2, 1 plus cosine theta. All right, so then that looks a little bit closer there. We have cosine 2 theta plus 1. That's almost that, but we have this 2 theta. So let's go ahead and make this theta over 2. So 2 cosine squared theta over 2 equals cosine theta plus 1. All right, now that matches that. So now we can plug in this 2 cosine squared theta over 2. So we have sine squared theta over, we still have this factor of 2 here, so 2. And then we have another 2 cosine squared theta over 2. So how does that help us? It will. So now we have to do something with our sine, hopefully something that will give us a theta over 2, because now we went and changed our theta to theta over 2. So we've got this sine double angle. I think it's only one of those, which is 2 sine theta cosine theta. Great. Well, that doesn't really look like anything that we need, but because we have a sine squared, let's go ahead and just square all this. So we have sine squared 2 theta equals 4 sine squared theta cosine squared theta. And again, we have this 2 theta, so let's cut that in half. So sine 2 theta equals 4 sine squared theta over 2 cosine squared theta over 2. All right, so now we have a sine squared theta, and that's what we need. So we'll replace that. So we've got a squared is equal to, so we'll replace this sine squared theta with all this. So we have 4 sine squared theta over 2 cosine squared theta over 2, all over this. So 4 cosine squared theta over 2. And now we can start canceling. So we cancel out a 4, cancel out a cosine squared theta over 2, and now we're left with sine squared theta over 2. Remember, this is a squared, so we'll take the square root of both sides, and we're left with a is equal to sine of theta over 2. All right, so I'll write that over here. A is equal to sine theta over 2. And hopefully b isn't too complicated. So b is equal to, let's pull out this negative and the ei5, because I think that's going to stay there. And then we have a, or a is this, sine theta over 2, 1 plus cosine theta, all over sine theta. And I think we can just go ahead and replace these with the double angles here. So sine theta is, so I'll just write these two up here. So we have sine 2 theta is equal to sine theta cosine theta, right? 2 cosine theta, 2 sine theta cosine theta. So that means sine of theta is equal to 2 sine theta over 2 cosine theta over 2. Now let's write the other one because we're going to need the other one. Cosine 2 theta is equal to 2 cosine squared theta minus 1. All right. So let's go ahead and swap out our sine theta here. So it's going to be b equals negative e to the I phi sine theta over 2, 1 plus cosine theta, all over that. So 2 sine theta over 2 cosine theta over 2. We can cancel out the sine theta over 2. So then we have 1 plus cosine theta over 2 cosine theta over 2. All right, so this 1 plus cosine theta, we can get that from here. So if we add 1 to both sides, then we have 1 plus cosine 2 theta equals 2 cosine squared theta. And let's go ahead and cut that angle in half. So 1 plus cosine theta equals 2 cosine squared theta over 2. All right, so there's our 1 plus cosine theta. So I'll write the whole thing out over here. So b equals negative e to the I phi. And then so our 1 plus cosine theta is going to be now 2 cosine squared theta over 2 all over 2 cosine theta over 2. Our 2's cancel. Our cosine theta over 2, one of those cancels. And then our b is equal negative e to the I phi cosine theta over 2. All right, so that means our second eigenstate is going to be, down is going to be, A is sine theta over 2, up, minus e to the I phi cosine theta over 2. Okay, we did it. We made it through. It was rough, but it's over.